So, what temperature does it take for glass to melt?
So glass doesn't have a set melting point like aluminum, right? Glass has, as it gets hotter and hotter, it gets more and more liquid. So at about 1400 degrees, this glass will slump under its own weight. So that means if I put a rod of glass and held it up on two fire bricks, right? At 1400 degrees, it's going to start melting and bending in the middle. Makes sense? And that can happen anywhere between 12 and 14. It depends on the formula of glass. We gather the glass out of the tank at about 2100 degrees. So at 2100 degrees, it is liquid enough that it's almost like warm honey. And so that's a good working temperature for us. Any higher than that, and it's difficult to take a really good gatherer glass. You can imagine going anywhere from like honey all of a sudden into like maple syrup, and imagine trying to get a small bowl of honey and on the end of a pencil trying to gather that honey. And you can get a little bit, but on syrup you're just going to barely get any. Make sense?
How does your forge power? What does it run on?
So I don't have a forge, I have a furnace, and the furnace is what holds the molten glass. With our furnace, it's powered by electricity. And so it's big industrial power. So it's not like a little outlet that you would have in your house. That's like 110. And that's a standard for appliances, for blenders, toasters, things like that. This is an industrial power. And so that's even bigger than like dryers and things like that. But it has a big plug, and then it runs it through a transformer. Transformers are those big things that you'll see on corners, on street lights and stuff like that. And that basically transfers our amps and volts. It brings our volts way down and it ramps our amps way up. And we feed all that energy to three big heating elements inside the furnace itself. Now, you can have gas-powered furnaces. And what you would need is a gas source, so either natural gas or propane, and then you have to have forced air, right? You have to have a blower because it won't get hot enough just with a pipe of natural gas lit. There are burners called Venturi-style burners, and you can probably even use that for aluminum, but for temperatures that we need to operate with, we have to have forced air. So I have a blower on that, and all it does is just rotate and forces air, mixes in with the gas, and we ignite the whole thing.
Do you often get burns while handling glass?
I'll get there's little guys like that, some of the annealing ovens. It's just like a chef dealing with knives all the time, right? And you're going to get little cuts and scrapes and things like that, but it's all part of the job. If I get burnt bad enough that I can't be around the furnaces, then that's really bad. This is how I make my living, and you need to be able to keep working. Just like if a chef cuts his finger off, then that's bad news.
How do you create shapes like balls or like bubbles almost?
Sure. I'll work on the end of a blowpipe, so a hollow stainless steel pipe. And I will gather the glass on the end of that big hollow stainless steel. Basically, it's like a straw, right? I'll gather glass on the end of that, and then that will allow me to actually inflate it. Push air into it with my lungs into that solid gatherer glass past the end of the pipe, and it will inflate it from the inside out. All the shaping gets done with just simple hand tools and rotation.
Does it take a lot of air pressure to like blow it into a bubble, or do you have to blow really hard?
You don't. The only time you ever have to inflate with any type of real pressure is in the very beginning, when I am putting a very initial core bubble into that solid gatherer glass, and you kind of have to break into that hot, soft gatherer glass. But on top of that, or aside from that, it takes only like a half a pound of pressure, and which is nothing at all. When you consider a lot of car tires are like 30 pounds of pressure, that's a tremendous amount of pressure. So for us, what we're doing, it's very gently. A lot of the times when I'm instructing students, I'll tell them, okay, now basically be whispering into the pipe, just barely be inflating, because all we're looking for is positive pressure just for light inflation. It's easier than blowing up a balloon.
How long does it usually take for the furnace to heat up to the right temperature?
So, it takes 5 days for the furnace to heat up. But that's an entire furnace, right? And all of this, all of the brick and the insulation material is all silica based. And silica is one of the only things that can really hold up, and that's semi-affordable, hold up to these type of temperatures. So that's even silica based glass is silica based. All of the masonry and fire brick, the refractory, it's all silica based. I have to bring it all up slowly and evenly so that everything is heating up at the same temperature. What I can't do is just turn it on full power, let it ramp up over 24 hours. I'm going to have all kinds of thermal cracking and things like that inside the furnace. So it takes basically 5 days to bring it up to temperature, 5 days to bring it back down. And I let it do it nice and slow to avoid any type of thermal stress.
What kind of tools do you use to shape the glass?
Simple hand tools. I'll use, there's specialized hand tools, even some of the shears and kind of like glass scissors, things like that. But they're specialized but really simple hand tools. And then one of our biggest shaping tools is just a folded up damp newspaper, and I'll burn it in, and that's what will allow me to kind of really compress the glass and shape it where I need it to go. That's as close as I'll come to actually touching the glass directly.
Do you need to wear any sort of protection from the glass?
I wear safety glasses all the time, and I'll wear safety glasses just doing anything, man. Really, even at home, drilling holes in walls and stuff like that. And that's just a pattern that I've gotten into working in all kinds of different fabrication shops, because you never know. I've drilled holes in steel, and then you go to blow out that little hole, and all those metal fragments, and you've gotten those things in your eyes, and that's real common. That's like a common thing. So, safety glasses all the time, doing almost anything. But aside from that, I don't wear any type of heat protection. If I'm working on a real big piece of glass, we have Kevlar sleeving and things like that to help reflect the heat. You don't want to use cotton or anything like that. Kevlar is the same thing that a lot of firefighter suits are made out of.
So how do you shape like glass bottles, like a beer bottle?
Those would be done off a machine. So all 99.9% of all the glass that we come in contact with today is machine made. Over 100 years ago, glass was mechanized. So they figured out how to take a big bunch of glass and then have basically machines, chop off the appropriate amount, insert air into a blow mold. So we have a mold, a steel mold that looks like a bottle, whatever bottle you want. Coke bottle, let's use that for example. It's going to be a multi-part mold that can close and then it opens up on several different hinge points. They'll shoot that bit of glass down inside of it, inflate it really quick. The glass takes the optic, it takes that mold, and then they crack that mold out, they cool it down, and it's just on a big circular, almost like carousel, where they just keep cooling these same molds down, filling them full of glass, inflate, get it out. Next one. For what we do, I don't use any type of blow molds unless it's for a particular job or something like that. Like right now I'm working on these 97 7-inch spheres. So I have all of these 7-inch spheres. I need to make almost 100 of them. It's advantageous to me. It's smart for me to get a blow mold made up, and that way all I got to do is get the thing set up and blow it inside the mold and it's set. As opposed to if I was doing them all by hand, I'd have to take caliper readings, making sure that it would take twice or 3 times the amount of time.
With like colored objects or sculptures that you make, do you use certain colored glass or do you paint it?
Yeah, you're absolutely right. It's certain colored glass. So I melt clear glass. I have a big furnace full of clear glass. I color each piece and each component individually. If I melted blue glass, then everything I make will be blue or some slight variation. So it winds up, let me answer this, sorry. So I color each piece individually, and I buy a color out of Germany and New Zealand. It's called Frit. I can buy either Color Bar or Frit. And Color Bar is exactly that. It's a big, maybe 16-inch by maybe 1-inch bar of pure colored glass, really densely colored glass. And I'll knock off maybe an inch of it, maybe 3 inches of this bar. I'll heat it up to 1,000 degrees, and then I'll pick it up, and then I'll work with it from there. Frit is crushed up colored glass. It looks like glass gravel. and I'll pour that in a tray, and I can roll my clear glass through it, and Brit is a more direct way of coloring the clear. But having an entire tank of clear, that allows me to be a lot more versatile, and that way I can make a red piece, and then a yellow, and then a blue, and then a white.
How long, or do you always have the furnaces running?
Oh, yeah, I do. I have my main furnace running all the time. It runs for 11 months straight. And I'll shut it down. Like I said, it takes 5 days to cool down, right? So, I'll shut it down for a month. I shut it down for the hottest 4 weeks of the year, usually at the end of July, halfway through July to halfway through August. I'll do all the other maintenance and things that the shop needs at that point. But once you bring the furnace up to temperature, it is more economical to keep it at temp than it is to cool it down and ramp it up, because that ramping up process, it eats a lot of juice, it eats a lot of electricity, and it's also really hard on the refractory. Remember we talked earlier about all the silica-based refractory? That's how you can crack your refractory, by cooling it down and ramping it up.
With the furnaces, what are they made out of? Are there certain insides that you have to have to the furnace? Like stone?
It's all basically what's called fire brick. In fire brick, you'll see pottery kilns are made out of a lot of the same material, really dense silica-based bricks that can be chopped with masonry saws and things like that. You can even file them down, but they're one of the only things that can hold up to those type of temperatures. Now, unlike brick, it's not really dense, and it doesn't have because we want everything to bring up nice and slowly. You don't want different layers that are heating up at different rates.
How long does it usually take once you finish making an object? How long does it usually take for it to cool down to handling temperature?
I cool it down overnight. But because the glass has to go through an annealing process, right? And especially handmade glass with all of these different thicknesses, we have to cool everything down nice and slowly, about a degree a minute. It takes 12 or 14 hours. The opposite of annealing is tempering, and you'll hear there's a thing called tempered glass. Usually they'll refer to windshields are tempered, right? And what that means is that they have made this windshield in a mold, again, like we were talking about, mechanized industrial glass is made in a mold, but instead of cooling it down really, really slowly, they'll cool it down extremely quickly using air jets, and that produces a tremendous amount of compression on the outside. Now, that's why when you break a windshield, it breaks into millions and millions of tiny little pieces. When you break a piece of our glass, it breaks into these big gnarly shards. You wouldn't want the shards in a windshield because that cuts people. What they'll do with windshields is that they will temper them, and then they'll also laminate it. And so it has like a urethane layer to help kind of keep all that glass from just going everywhere.
Do different glasses melt at different melting points?
Yeah, they do. And there are, we use a particular formula of glass here at the shop that is engineered to do exactly what we do with it. So it's meant to be made in an offhand fashion. That's to say, this is not particularly good glass to be made to make industrial glass for blow molds and stuff like that. It has a really long malleability range, so it gets hot at about 1400 degrees. It gets nice and viscous at like 1700 degrees, and then it keeps that viscosity, keeps that malleability for a nice, relatively long time. For industrial glass, Coke bottles, things like that, it's going to get hot it's going to get really viscous at a very low temperature, but it's also going to set up like that because they want to shoot it into that mold, for it to take the mold, and then they want to get it out and get another one right back in that mold, and do it just as fast as they can.
What was the longest time took you to build? What was the hardest thing to build for you?
Sure. You can work on any given piece of glass indefinitely. As long as you keep it hot above 1100 degrees or so, you're not going to experience any type of thermal shock. If you let the piece of glass, whatever you're working on, at any point cool down below that, say, 800, 900 degree range, it's going to crack. It's going to experience a thermal shock and it's going to crack. So, as long as you keep something hot, you can work on it for 5, 8 hours. And people too. We'll make big sculptures and stuff like that here in the shop. What I'll do is I'll pre-make components, and I'll let those cool all the way down, I'll lay them out in whatever kind of pattern I want. I'll heat them up nice and slowly, and then I'll roll them up and work with them that day. And it may take 2 or 3 hours just to make whatever we're making.
Oh, okay. Those are like mainly all the questions I have. But
Pretty good pile of questions there.
Yeah, that was great. That's a good job.
That's
a good job.
Those are great questions.
so
like when you melt these, those are industrial glass. Is that like you can't really do much with them other than?
I can't remelt. Like, you're talking like the bottles and stuff.
Yeah.
I can't take those and put them in my furnace and make blown glass out of them.
Right.
Because all these different formulas of glass, they're not compatible. So it's like oil and water. Have you ever poured like a little bit of vegetable oil in a water bottle and a little bit of water on top of them? The vegetable oil and the water are going to separate, right? The same basic kind of idea happens with glass. As glass heats up, it expands. As it cools down, it contracts. If the two different formulas expand and contract at different rates, it's going to be incompatible, and it's going to, on a molecular level, not bond, and everything's just going to basically crumble apart. You'll come back, a lot of times if you're having compatibility issues, you can make the piece and it's fine when it's hot, and you can come back the next day and inside the annealing oven where we cool everything down slowly, the piece will just be in crumbles in the oven. So stuff like this, all the bottles, I have a fusing kiln that doesn't get as hot as the furnace. I'll put them inside the fusing kiln. I'll ramp them up nice and slowly. It hits 1400 degrees, and that's when those bottles flatten out. And then from there, it brings it back down nice and slowly. And I'll have a chance to take a look at them the next day.
So with clay, like if you mess up a part, you can almost kind of like squish it back and then remold it. Can you do the same with glass?
Not so much. If it is clear only, it's smart for me just to start over. Just take that clear. I have a clear only bucket in the back. The clear I can directly recycle. So the clear glass that I am melting, if I mess up something, I can just put it in the bucket, let it break apart, and then I'll throw it back in the tank at the end of the day and remelt it. Anything with color on it, I can't directly remelt because it's going to contaminate my clear. Now, at the end of, remember how I'm saying that I keep the furnace on for 11 months out of the year? I melt all the glass in a big crucible. You see that big white bowl? Those 2 big white bowls? Those are crucibles. And crucible holds the molten glass itself. So, at the end, those crucibles need to be replaced every year. At the end of the crucible life, I can remelt all of my a lot of my mistakes from throughout the year. So anything with color on it, I can put back in the crucible. I know that it's going to start making basically like a bluish gray glass the more and more recycled glass I know.
So are all of your crucibles are they all ceramic?
It's all silica base. So it winds up being glass is silica base. Ceramic is silica base as well. And it's thought that some of the first glass was made in a pottery studio maybe 2,700 years ago. Because they have all the necessary components. They have silica, they have glazes, they have heat, and those are some of them, especially silica and heat, are the main components that we need to make glass.
Got no more?
Yeah, I don't have any more questions. So.
All right. Those are good.
Yeah,
I think you got some material.
Nice job, bud.
Nice meeting you.
Nice meeting you.
Thank you for interviewing me.
Hey, well,
and
thank you for interviewing me. Yeah.
Being interviewed.
Yeah.
There you go.
You did a great job. Nice.
Thank you.
All right. Thank you for your time.
No problem, guys. Have a great day.
You too.